The goal of this video is to take an equation that's in standard form like this and come up with a graph without having to do a table of values. So what we're going to do is switch this equation from standard form into factored form. That's going to help us find the x-intercepts. From the x-intercepts we can find the vertex. We can also find the y-intercept very easily. Axis of symmetry, and then come up with our sketch. We're going to do a few examples here. I'm going to walk through this first one step by step, and then we'll kind of summarize these next two because they're similar. And then I'm going to do one extra where it's not factorable. So we're going to be forced to put it into vertex form and get the graph that way. All right, so let's get to it. We've learned how to factor equations like this. So we need to add up to be 8, the middle number, and multiply to be the last number, 7. So what two numbers satisfy this condition? Turns out it's 7 and 1. 7 plus 1 is 8, and 7 times 1 is 7. Alright, so our equation can be now expressed as x plus 7, x plus 1, as we've learned for the patterns where we have a 1x squared plus bx plus c. Alright, to find the x-intercept, we must let y equal 0. So we can say x plus 7 times x plus 1 is equal to 0. As we learned previously, we can now write it as x plus 7 equals 0, or our other case is where x plus 1 equals 0. So we've got x equals -7 or x equals -1. Those are our x-intercepts. The points are going to be at -7, 0 and -1, 0. To get our vertex, we can simply, if you imagine we've got our 2 points, the x value of our vertex is going to be in the middle. So what we can do, and that's just symmetry, right? What we can do is take the average of our x-intercepts. So just take our first one plus our second one and divide that by 2. So we've got -7 plus -1 over 2, which gives us -7 plus -1 is -8. Then divide by 2 gives us -4. So what we can do now is substitute this x value, which is the x-coordinate of our vertex. We sub this into our original equation. Now I have a choice here. I could toss it into this, or I could toss it into this. It's going to yield the same answer because they're equivalent. Let's do it into the original. So we've got -4 squared we've got then plus 8 times -4 plus 7. All right, if you do this carefully, you'll get a y value of -9. So our vertex is going to be -4, -9. Now, it's actually quite convenient to have standard form here. So let me just write that down. Given we have y equals x squared plus 8x plus 7, we can see the y-intercept very easily because we know when we find the y-intercept, we let x equals 0. And look what happens when we let our equation equal, or sorry, our x value in our equation equals 0. We get just this final number because these two numbers disappear. So we're just going to be left with the 7. So we can see with standard form exactly what our y-intercept is going to be. It's just this number without an x in it. So we've got a y-intercept of 0, 7. So with these points, with our x-intercepts of -7 and -1, our vertex at -4 and -9, and this y-intercept of 0, 7, we can graph this guy. Now because this particular graph has a value that goes down to -9, I'm going to need to extend this a little bit because this is -1, 2, 3, 4, 5, 6, 7, 8, 9. Just do my best to extend that a little bit. Otherwise, you can just change the scaling at like count by 2s. Oh yeah, so let's first find our axis of symmetry, which is just the x value of our vertex. That's the equation of it. Let's draw that in first. So we've got 1, 2, 3, -4, like that. I can draw in my x-intercepts which were -7 and -1. 1, 2, 3, 4, 5, 6, 7, boom, and -1. My y-intercept was at 0, 7, 2, 3, 4, 5, 6, 7. All right, and then because of symmetry, at this height of 7, we went 1, 2, 3, 4 to the right of my axis of symmetry. I can now go 1, 2, 3, 4 to the left of my axis of symmetry to get the other value. So you can see all this, and don't forget to also label your vertex, which is at -4, -9. So right here, and label that. All right, so we can now try our best to sketch the parabola. That's pretty good. There it is. So let me quickly now warp ahead and just narrate how to do these next two examples. For example 2, we're going to do the same process. We're going to try to factor this expression and then get the x-intercepts, take the average, find the x value of the vertex, substitute that into the original equation, get the y value of the vertex, find the y-intercept, find the x of symmetry, and graph. Now this one's factored a little differently because we first need to notice that the leading coefficient is not 1. So we need to multiply the a value and the c value, including this negative. So we get 2 times -6 gives me -12. So we need to add up to be the middle term, which is -1, and then multiply to be this -12. Now, numbers that satisfy this condition would be -4 and 3. -4 plus 3 is -1. -4 times 3 is -12. All right, so this works a little differently than last time, but we need to now look at our original equation, so 2x squared minus 6. But instead of writing the -x, we're going to now replace -x with these two values we found. And we're going to go -4x plus 3x, which is equivalent. -4x plus 3x is -x. Now we can factor by grouping. We can look at the first two terms, factor that. We can factor a 2x here. So we got 2x times x minus 2. And then we can focus on the second two terms, find the GCF of that, which is 3. So 3 times x minus 2 is equivalent. Now, because we have a x minus 2 and x minus 2, we can factor these expressions, right? That's x minus 2 there, times the 2x plus 3. So there's our factored form for our equation. So we can let y equals 0 to find our x-intercepts. So as a result, we get x equals -3/2 and x equals 2. As before, we just take the average of our x-intercepts to find the x value of our vertex. So that's our -3/2 and our 2. We do that and we get we get 1/4. We sub that into our original equation, which gives us this value of negative 49 over 8, which is approximately equal to 6.125. So our vertex is at 0.25, 6.125. So we'll keep that in mind for later, where after we find our y-intercept, which is negative 6, our axis of symmetry, which is 1/4, we can put it all together and get our graph, right? Our vertex. You can see how getting those decimal numbers help with the actual graphing, because it's hard to maybe know where 1/4 is, which is 0.25, so that's where I went. And then this is your negative 49 over 8, which is exactly equal to 6.125, negative 6.125. All right, that's our second example. I'll just quickly go over our last one here. So we've got x squared, negative x squared plus 6x minus 9. Now, once you factor a negative here, because we don't want to have a negative leading coefficient, we just factor out a negative in front. Now we've got a positive value. You can factor this using your traditional way, where we just look at, okay, what adds up to be the middle, multiplies to be the last. So we've got, let's see here, negative 3 works. This is a perfect square trinomial, right? Because these values are the same. So we end up getting negative x minus 3 all squared. And to find the x-intercepts, we let y equals 0. So we got negative x minus 3 squared equals 0, which is the same thing as saying x minus 3 times x minus 3. And we have, in this case, you can kind of see our x-intercepts are at the same place, which just means that's where our vertex is. Our vertex is at x equals 3. So look, when we find, look, this is going to kind of come together here. So if I find the x value of my vertex, look, I just average them. If it's the same value, it's just going to be the same value again. And then we substitute that into our original equation. So our vertex is at 3, 0. And find the y-intercept, letting x equals 0, we get 0, negative 9, and we can graph this. So let me just kind of quickly show you how to graph this, because see these other ones here, this other one here, we can have the vertex down here, and our x-intercepts are there. So it's kind of a nice way to graph it. But this case, our x-intercepts are here, and we have no really other reference other than the y-intercept, which is down here. So let's jot that point down. We have a y-intercept of 0, negative 9. So there's our 2 points. But take a look up here. This equation can be expressed as negative x minus 3 squared. So we could actually use our step pattern that we learned before. We're going to go 1 over, 1 down. We're going to go 1 over, 3 down. We're going to go 1 over, then 5 down. That's because my a value here, you can see, is negative 1. All right, so let's use that from our vertex, which we know is at 3, 0. We can use our pattern, 1 over, 1 down, 1 over, 3 down, 1 over, 5 down, and look how that works nicely. It hits our y-intercept. We can go the other way, same thing, and this is going to give us a nice clean graph. There it is. I just wanted to show one more example, because sometimes you cannot factor the expression. So what do you do when you're given an equation in standard form and you're asked to graph it? Yeah, you could always find the table of values and do it that way, but instead of putting it into factored form, we can instead put it into vertex form. So we learned a method for that. We learned complete the square. So what we're going to do first is bring this 2 out front. So we get x squared minus 2x, then plus 5. Right? If you FOIL this out, you'll get this again, and then plus the 5. Okay. Now, using our complete the square technique inside the bracket here, we're going to take this -2, we're going to have it and then square it, which gives us a -1 squared, which means my zero pair, I'm going to be adding 1, subtracting 1. So x squared minus 2x plus 1 minus 1 plus the 5. This here is a perfect square trinomial, which turns out to be x minus 1 squared. Alright, so we're going to carefully FOIL out this, and we get 2 times x minus 1 squared minus 2 plus 5. So we've got 2 plus 3. Alright, so here's our equation in vertex form. So we can quickly see our vertex is going to be 1, 3, which comes from this value. We just switch the sign. It's -1 here, it becomes 1 here. I'll leave that colored. And then we'll go, the 3 goes here. All right. Now, this was not factorable, right? So we also notice that our vertex here is above the x-axis, and we can see here that it's concave up because this is a +2 in front of the x squared. So it's above the x-axis, right? My x-axis is here, and so it's up, my vertex is up here, and it's concave up. So we're not going to have any x-intercepts. So we can't use that to help guide our drawing. We could find our y-intercept still, and as you can see in our original equation, we see the 5, so our y-intercept is going to be 5. Let me just show you this formally. So we're going to let x equals 0. Our equation is 2 times 0 squared. What was it? Minus 4 times 0. That is plus 5. So we get y equals 5. All right, this will be enough to graph it. We know our pattern is going to be, because our a value is 2, we've got 1 over, it's 2 times 1 up. So we've got 2 up, 1 over 2 times 3 up. So we've got 6 up. And if we have space, we'll do the last one, 1 over 2 times 5 up, which is 10 up. So if you use the pattern, the vertex, and the y-intercept, we can get the graph, which turns out to look like this, right? Our vertex was at 1, 3. Our pattern told us we went 1 over 2 up, 1 over 6 up. So you'll see that here. It'll go up all the way up 6 up. But there you go. So using the pattern, and we'll see also our y-intercept 0, 5. Using our pattern, using the y-intercept, using the vertex, we've got our graph. So these are the the strategies that could be used, given something in standard form, y equals ax squared plus bx plus c, we can choose to put this into a factored form or vertex form to help us graph it more easily. So like this form very quickly and easily helps us find the x-intercepts. And this form here very quickly and easily helps us find the vertex, and we can use the pattern to get the other points. I hope this helped.